Welcome back to the Dargslan series, part 15, and this is the honest one. Look, your RAG pipeline works beautifully in the demo, but the moment you point it at real documents, it starts hallucinating, missing obvious answers, or confidently citing the wrong paragraph. Most tutorials wrap up around part 13 and leave you there. We're going further. 5 concrete tuning techniques to drag your quality from a sad 60% up to a respectable 90%, and we're going to measure it, not vibe check it. So before we touch any knobs, let's diagnose. 4 symptoms, and if any of them sound painfully familiar, your retrieval layer is the culprit, not the language model. You ask for the refund policy and get the shipping page. The answer is literally Ctrl+F able in your docs, but the bot swears it doesn't know. Same question gives you 2 different answers back to back, or worse, it hallucinates a confident, detailed, completely wrong response. Notice the pattern. Every one of these is a retrieval failure dressed up as a generation failure. Which brings us to rule number 1, measure, don't guess. Before you change a single setting, sit down and write 20 real questions your users actually ask, with the 20 answers you know are correct. Then loop through them, run your RAG, and check if the expected string shows up in the response. That's it. 30 lines of Python and suddenly you have a scorecard. Maybe you're at 13 out of 20, 65%. Ugly number, but now it's an honest one, and every tweak from here on either moves it up or it doesn't. So with that scorecard in hand, here's where almost everyone should start: the chunks themselves. Honestly, 80% of bad RAG is just bad chunks. Pull 10 of them out and read them aloud. If you're seeing half sentences at the edges, bump your overlap to 200 tokens, giant blobs mixing unrelated topics. Drop chunk size to 300, not 1500. Code split mid-function, split on the triple backtick first. Tables turn to gibberish, extract them separately as markdown. Re-ingest, rerun eval, and watch that score jump 10 to 20 points. Once your chunks are clean, the next leak is on the input side. Users type things like, "How do refunds work?" 4 vague words. Your docs say return policy or money back guarantee. Those vectors don't land near each other. So have a small LLM rewrite the query into 3 or 4 alternate phrasings, retrieve for each, then dedupe and cap the merged list. It's cheap, it's maybe 50 lines of code, and it routinely buys you another 10 points on your eval. Now here's a failure mode. Pure vector search will never fix. A user asks for SKU 1234 or section 4.2, and the embedding model shrugs because semantically those tokens mean nothing. Bring back the boring old hero, BM25 keyword search, and run it alongside Chroma. Rank BM25 is 1 pip install, you tokenize the same docs, and you get exact match recall for free. Then fuse the 2 ranked lists with reciprocal rank fusion, and suddenly your long-tail identifiers stop disappearing into the void. Hybrid search gets you better candidates, but the next leak is in the ranking itself. Embeddings are fast and blunt. They score every doc independently. A cross-encoder actually reads the question and the candidate together, so it's slow, but it's brutally accurate. The trick is to use both. Retrieve 20 wide with your vector store, then let MS Marco mini-LM rescore those 20 and hand the top 3 to your LLM. 1 pip install, maybe 50 milliseconds extra, and your precision jumps noticeably. Now that you're feeding the model better chunks, give it a better prompt to work with. Back in part 13, we used a basic template, fine but loose. This one numbers every chunk so the model can cite them in brackets, forces an explicit "I don't know" when the answer isn't there, and flat out forbids leaning on general knowledge. Small wording changes, but they slash hallucination and make every answer auditable. So let's tally it up. Starting from that 65% baseline back in part 13, better chunks gave us the biggest single jump, 10 points. Then query rewriting, hybrid search, re-ranking, and the Titan prompt each added another 5. No single fix is magic on its own, but stack them and you go from 65 to 95. That's the whole point. Compounding small, measurable wins beats chasing 1 silver bullet. Now, before you go stack all 5 of those fixes tonight, Let me save you some pain with the anti-patterns that quietly wreck this process. Don't tune without measuring. Feels better is not data. Don't swap your LLM first. 9 times out of 10, the bug is in retrieval, not generation. Don't crank K to 20 hoping more context helps. It just dilutes the signal. Don't ship 5 changes at once because you'll never know which one moved the needle. And please don't build your eval set from memory. Use real questions your users actually asked. So here's the order I'd actually run it in. Biggest wins first. Start by building eval.py. 20 question-answer pairs, score your baseline. That's your 15% right there just from finally being able to see. Then eyeball 10 chunks for noise, another 15. Tune chunk size and overlap and re-ingest. That's your biggest single jump, around 20%. Then layer in hybrid search and a re-ranker for another 15, especially if you're indexing code. And only at the very end do you polish the prompt or reach for a bigger LLM. That's maybe 5%. Stop when your eval says good enough. Don't optimize past your signal. So tonight, before you close this tab and forget everything, here are 4 things you can actually do this week. None of them take more than an hour. Write eval.py with 20 real questions and run your baseline. Peek at 10 random chunks and just read them like a human. Drop in BM250 CAPI from rank BM25 for hybrid search and rerun your eval to measure the delta, and finally swap your 8B for a 70B, but only after retrieval is fixed, because if quality doesn't move, you've just proved the LLM was never your problem. Now, an equally important question: when do you stop? Because tuning is addictive and diminishing returns are real. Past about 85 to 90%, every additional point costs 10 times the effort. 4 signals tell you it's time to ship. Your eval set hits 95% plus, and the rest are genuine edge cases. Real user feedback is positive. You've burned 80% of the project on the last 5%, or you catch yourself flipping top K from 3 to 4 to 3 to 5. That last one isn't tuning, it's fidgeting. Ship it, and let real queries become your next eval set. So let's pull the whole thing together. 5 takeaways worth tattooing somewhere visible. Bad RAG is almost always a retrieval problem, not the model. Fix chunks and queries first. Build eval.py before you touch anything else, because without numbers, you're just vibing. The 5 fixes: chunks, queries, hybrid, re-rank, prompt, compound, and can take you from 65 to 95 in a single session. Add them one at a time, re-eval after each, and when you hit good enough, stop tuning and ship. Real users will find what your eval set missed. And here's your cheat sheet. Screenshot it, print it, tape it to your monitor. The left column is your workflow. Build eval.py with 20 scored pairs, peek at random chunks, retrieve wide and re-rank narrow, refuse to guess, and fix 1 thing per round. The right column is your toolkit. Rank BM25 for keyword search, sentence transformers with MS Marco Mini LM L6 for re-ranking, RRF to merge results, citations for trust, and the discipline to stop at 90%. That's the whole playbook on 1 page. And that closes phase 3. Your RAG actually works, and more importantly, you can prove it. But a Python script in a terminal isn't a product. So part 16 kicks off phase 4 with Open Web UI, a browser interface for Ollama with multi-user support and persistent chats. 1 Docker run command and you've got something you can hand to a teammate. 15 down, 9 to go. See you in the next part.